Today we are going to talk about ellipses and circles. We're going to talk about how we can graph them and analyzing those graphs. And then we're going to talk about how you can identify if something is an ellipse or a circle from the equation. So first let's look at our standard form. It's the quantity of x minus h squared over a squared plus the quantity of y minus k squared over b squared equals 1. Now in this particular format, the orientation of our ellipse is horizontal, meaning it looks like an egg lying on a table. It's laying side to side. Its longer or major axis goes from left to right. Now that gives you our where our vertices are located at. Because the larger value is under the x, it is stretched out more in the x direction. Our b value is smaller than our a value, so it's not stretched out as much in our y direction. The center is still hk. The vertices and co-vertices are what's going to be important, so make sure that you definitely want to focus on the things that I put stars on. Now, if we want to take our parabola and turn it so that its orientation is vertical, we do so by putting the larger value this time underneath the y squared. So you'll notice we still have x minus h squared over b squared plus y minus k squared over a squared equals 1. But this time the a and the b have flip-flop spots because now our larger value is underneath the y. Our center is still hk. Now our vertices and co-vertices have flip-flopped because now our larger values are up and down and our smaller values go left to right. And this will all become a little more clear as we go through the process of finding these equations. And we're going to really just focus on them, really quickly, so that we can get the main ideas of what to look for. So let's look at an example. In this example, let's think about why we know it's an ellipse. So we've got our x minus h squared plus our y minus k squared equals 1. Our larger value is under the x, so I'll call that a, and I'll call that b, and it's a squared and b squared. So the first thing we want to find is our vertex. Well, we'll call it a center this time, which occurs at -2, +1. Do you see how this is the opposite of h and the opposite of k? Remember, if it's inside the parenthesis, it's that opposite effect will occur because it's where that value equals 0, and when you solve it, it moves that thing to the other side and just flips its sign. Now, our a squared is 9, so our a value is plus or minus 3. Our b squared is 4, so our b value is plus or minus 2. Now this is what's going to change our x values, and those are going to be vertices So the b's were under the y, so they're going to change the y values, and they're going to be called co-vertices. Now let's go ahead and do that. So our vertices, we're going to have two of them. You're going to take our center value. For the x's only, we are going to add 3 and subtract 3 because of our a value being plus or minus 3. And so if I add 3, I get 1, 1. You're not changing the y's at all. And then if I subtract 3, I get negative 5, 1. Those are our vertices. Our co-vertices. We're going to add or subtract 2 to the y value. So our x value stays negative 2. Our y value, we're going to add and subtract 2. So if we add 2, we get 3. If we subtract 2, we get negative 1. Now we're ready to graph it. First, go over and put on your center value. Now, remember our x value changed by plus or minus 3. So in the x direction, I want you to count in the x direction, plus 3 and minus 3. That's where our vertices come from. So if I count in the x direction 3 to the right, that's adding 3. That's the point 1, 1. That's our vertice 1. If I count 3 to the left, that's our vertice 2. That's the point negative 5, 1. Now remember our b values was a change by plus or minus 2. That's where our co-vertices came from. And we changed the y value. We counted up 2 and down 2. Those are our co-vertices. And then you just make a little egg shape. At this point, we don't really need to know much more than that. Let's look at another example. Now this example, everything's kind of jumbled up. So we want to put our x's together. We want to put our y's together. And then we want to bring any numbers that are involved to the other side. Now let's look at our standard form. It's one of the two. It's x minus h squared over a squared plus y minus k squared over b squared equals 1. Now it doesn't really matter what you call the a or what you call the b at this point, but just so we have something written down the page. So the first thing I need to do is I don't like the fact that there's a 4 here in front of my x's. So I am going to take out a 4 from each of those. I'm going to leave a little blank there, and we'll discuss that blank in a minute. And there's nothing in front of the y, so we can call it a 1. And so we're going to do something from Algebra 2 called completing the square. Now this is the easiest way to do it. Half of this number fills the spot next to the x. So x plus 3, and then that's squared. Now think about what would be hanging off the end. 3 squared would be hanging off the end, so that must be a 9. So really 4 times 9 has been added to the left side, so we're going to add 36 to the right side. Now let's do the same thing for this one. Half of negative 10 fills the spot. 5 squared fills this spot. Whatever we add to one side, we have to add to the other side. So I don't have a lot of room. Now let's think about what that is, and let's make that a little prettier for you to see. And then 3 plus 36 plus 25 is 133. No, that's not right. 3 plus 36 plus 25 is 64. That's better. Okay. Now, look at the difference here. We have numbers underneath our quantities, and we have it equal to 1. So whatever number is sitting here, we're going to divide every piece of our equation by that number. And then we're going to be able to reduce. So we get x minus 3 squared over 16 plus y minus 5 squared over 64 equals 1. So now it's in standard form. Now let's analyze some things here. The center is at 3, 5. The larger number is under our y. Put a little y there to remind us. So our a value is plus or minus 8 in the y direction. Our b squared is under our x, that's 16. Put a little x here. So that's plus or minus 4. So to graph it, here's our center at 3, 5. I'll pull this down here a little bit. And so in the y direction, we're going to count 8 up and 8 down. So if I count 8 up, way up here, and then I have to count 8 down, those are my vertices. And then in the y direction, I have to count plus or no, I'm sorry, in the x direction, I have to count plus or minus 4. Those are my co-vertices. And then I make my egg shape. So that is getting in a standard form, probably the hardest part. The graphing of these doesn't have to be anything horrible. Just remember, if it's under the x, that's how many you go in the x direction. If it's under the y, square root it. And that's how many you go in the y direction from the center point. So there you go. Those are ellipses. Now let's talk about some circle stuff. Here is the standard form of a circle. I'll write it a little bigger for you. Where HK is our center and r squared gives us r, which is our radius. Sometimes in a calculus class you want to split the circle in half, so I just wanted you to kind of see that equation for future reference. And it's y equals plus the square root of r squared minus x squared is a very simple version of that top of the circle. And the bottom of the circle is negative r squared minus x squared. We're not going to use that any more than what you see right there, but I just kind of wanted you to see what those equations look like. Because sometimes it's important to kind of split that circle into two pieces. For our purposes, this is what we want. Let's look at an example with circles. So if you look at this example, the reason we know that it's a circle is they're both squared. There's a positive between it, and it equals a number. Now, a circle is an ellipse. It really is. It's just a perfect ellipse where you are going in the x and the y direction. The major and the minor axes are the same length. So it's just a perfect ellipse. Our center for this would be at 2, -5. Remember, you're going to switch those signs. And then, since our radius squared is 9, our radius is 3. Now, the reason we don't put the plus or minus, it's a length, so you just always assume it's the positive version. And then let's graph it. We're going to go over to the point 2, -5. We're going to count 3 up, 3 down, 3 to the left, 3 to the right. Put a little center there, and then make your circle. Now let's look at part B. Part B is taking it a little further. We know the center, so we know HK is 2, 0. But this time they gave us the endpoints of a diameter. So we're going to deal with that in a minute. But we know right now that it's going to be x minus 2 squared plus y minus 0 squared equals some r squared. And that's the part we don't know. So let's label what we do know. We know our center is at 2, 0. We know that the endpoints of our diameter are at -5, 0 and 9, 0. That's -4. -5, 0 and 9, 0. So let's think about that. That is 7 units this direction and 7 units that direction. So our r must be 7. So that's x minus 2 squared plus y minus 0 squared equals 7 squared, or you could put 49. And then let's graph the circle. So we would just go 7 up from there, and also 7 down from there. And then we would make our circle. And there you go. There's a circle example. Now, the circles we've been given are in standard form. So there are times we have to get it into standard form, and we'll play with that here in a little while. Let's look at another example. It says, find the coordinates where the point of a line intersects a circle. Find the coordinates of the points where a line intersects a circle. Now let's just think about it for a minute. We can have a circle, and a line could never hit it. It could hit it once, or it could hit it twice. So we might not get an answer at all. We might get one answer, or we might get 2 answers. So how do you figure it out? Well, we're going to use a trick of systems of equations. We're going to take this, and we're going to substitute it in for the y. So we can use substitution. So we get x minus 7 squared plus x minus 8 plus 5 squared equals 16. Well, x minus 7 squared, let's actually multiply all that out. That's going to be x squared minus 14x plus 49. Now let's think about this little piece right there. Inside, it's really x minus 3. Now when we square that, we have to FOIL it. So we get x squared minus 6x plus 9 equals 16. Now, in order to solve that, let's pull some things together. Let's make it more like a quadratic we're used to. So that's 2x squared minus 20x. Now I'm going to add the 49 and the 9. That's 58, but I have to subtract 16 from both sides. So that would be 42 equals 0. Now what's really nice about this quadratic, if you don't like factoring and you want to use a quadratic formula, fine. I always like to check to see if I can factor. Now obviously they're all divisible by 2, so we can factor out a 2. But then it does factor to be x minus 7 and x minus 3. And then we get two values, x equals 7 or x equals 3. Now that means that it was a circle and the line cut through it in two places. So we want actual coordinates of points. So we know that y equals x minus 8. So for our first point, if we put 7 right there, we get 7 minus 8 or negative 1. For our second point, if we put 3 right there, we get 3 minus 8 or negative 5. And so there you go. There's an example of how you can blend lines and circles together when we're looking for where they might intersect one another. Now our last examples are just kind of identifying what something is and then trying to get it in the correct form. So, for example 5a, it says, identify the type of conic it is, and then put it in standard form. So the first thing you want to do is find your highest power. The highest power on my x is squared, the highest power on my y is squared, and they are both positive. If that happens, so they're both squared, and they're both positive, they're either a circle or an ellipse. But which one? Well, see the coefficients? See how this has a coefficient of 9 and this has a coefficient of 4? Because the coefficients are different, it is going to be going in different lengths in the x and y direction. So it is an ellipse. Now, it says to put it in standard form. So our standard form is x minus h squared over a squared plus y minus k squared over b squared equals 1. So we're going to put the x's together. Luckily for us, we only have that one x value, so we don't have to complete the square from Algebra 2. But this one has another y, so it needs completed. Put in parentheses if you want to say. And then I'm going to move that 32 to the other side, making it positive. And I'm going to put a little plus blank over here because I'm going to have to add something onto both sides. So we're going to get 9x squared is good to go. We're going to take a 4 out of each of these. We're now going to complete the square. Let's remember that process. Half of this number goes next to your y. That's a 1. 1 squared fills that spot. 1 squared is 1. There's a 4 here, so technically I have added a 4 to the left side, so I have to add a 4 to the right side. And I get that that's equal to 36. Now, the only difference in standard form with what we have and what standard form is that it's got to equal 1, so we're going to divide everything by 36. And then reduce, and then we're ready. So it's x squared over 4 plus y plus 1 squared over 9 equals 1. So what do we know about this ellipse? We know the center is at 0, negative 1. In the x direction, we're going to go plus or minus 2 because under the x is a 4, square root that get 2. In the y direction, I'm going to go plus or minus 3 if I were to graph it. So there's identifying a conic and getting into standard form. Let's look at this one. Our highest power on our x is an x squared. Our highest power on our y is a y to the first. So it's a y equals x squared. It is a parabola. Okay. So we want to get it into standard form, which is y equals a times x minus h squared plus k. So how do we do that? Well, let's get the y's to one side and everything else to the other side. I don't like the fact I've got this front number here. I'm going to divide everything by -4. So now I'm going to use my formula for a vertex. I know my a value is 1/4. So that's going to sit right there. I just got to find my hk. So remember, h is negative b over 2a. Well, b is 1, so negative b is -1. 2 a's is just 2 times 1/4, which is 1/2. And so that's really -1 divided by 1/2 is the same as -1 times the flip of 1/2, which is -2. And then I'm just going to plug it in to my equation here so that I can find my k. So if I plug -2 in, I get 1 minus 2 minus 4, which is -5. So now I found my hk is -2, -5. I know my a value is 1/4, so I'm going to put those back into my standard form equation. And then I got it. So it's y equals 1/4 x plus 2, it's the opposite of h squared, plus k as it sits. So when we add a -5, it is a -5. And so there you go. That is our parabola. If we were to graph it, we would start at -2, -5. We would maybe plug something into the left of it and to the right of it, and go from there. Let's do one last one. Identify the conic. The highest power on x is x squared. The highest power on y is y squared. That means it's either a circle or an ellipse. The coefficients match, so it is a circle. So then write down the standard form of a circle. And we want to get our equation to match. So get the x's together, plus a blank if there's only 2 pieces. We need there to be 3 pieces. Get the y's together, plus a blank if there's only 2 pieces. Move your number to the other side, and however many blanks you have, you're going to put that same amount of blanks on the other side. There's no front coefficient. That's great because we can just do like that. We just got to get the numbers to work. So how do you do that? We're going to put half this number in this spot. Half of 2 is 1, so it's going to be x plus 1. Square 1, fill that spot. 1 squared is 1. Put it in both places. Now y minus 3 has to fill that spot, half that number. 3 squared goes here. That's 9. So we're going to put 9 right there. And that answer is 16. So the center of this is -1, 3. The radius is the square root of 16, or 4. There you go. So that's everything, kind of a simplified version of everything you need about circles, ellipse, and ellipses. And then identifying a conic from the equation. And here is your homework.